For decades, quantum computing has shimmered on the technological horizon, promising unimaginable computational power, yet always remaining just out of reach, tangled in the fragility of quantum states. But in a quiet, calculated pivot from theory to engineering, Microsoft has just taken a stunning step forward. They've unveiled the Majorana 1 chip, the world's first topological quantum chip, and perhaps the key to finally unlocking practical quantum computing. Traditional quantum computers are marvels of physics and nightmares of fragility. Their qubits, the fundamental units of quantum information, are like soap bubbles, beautiful, complex, and easily burst. Stray photons, subtle vibrations, or even the faintest whisper of thermal energy can collapse their delicate quantum states. This vulnerability, known as decoherence, threatens the accuracy and reliability of quantum computation. To compensate, traditional systems depend on massive error correction, requiring millions of physical qubits just to support a few stable logical ones. It's like trying to build a cathedral out of sand. Every grain needs to be perfectly positioned, and even then, one rogue wave of noise can bring it all down. Scaling such systems to useful levels has long seemed impractical. Microsoft's approach turns this problem on its head by using a principle from mathematics: topology. Rather than encoding quantum information in particles that can be easily disturbed, they encode it in topological features, stable structural properties that resist local noise. Imagine tying a knot in a rope. Shake the rope, move it around, and the knot remains. That's the power of topology. And it might be the key to a new kind of quantum computing. The theoretical backbone of this approach is the Majorana particle, first proposed in 1937 by the brilliant Italian physicist Ettore Majorana, who would mysteriously vanish not long after. The particle he predicted is unique. It is its own antiparticle, making it ideal for fault-tolerant computing. But creating such particles in the lab proved elusive. For decades, they remained a mathematical ghost. Until now. After 17 years of intensive research, Microsoft has developed a system that can reliably produce and manipulate Majorana particles. By engineering a precise combination of materials, a hybrid nanowire made of semiconductors and superconductors, they've created a new environment where these exotic particles emerge naturally. In this system, quantum information isn't stored in a single particle or location. It's spread out, protected across the structure, making it far more resilient. This is the core of the Majorana 1 chip, a working prototype with 8 qubits that demonstrates for the first time the viability of topological qubits in hardware. It's not just a theoretical leap. It's a functioning piece of technology that proves the concept works, and it changes the game. Where experts once projected that useful quantum computers were decades away, this breakthrough shifts the timeline dramatically. The challenge has moved from abstract physics to applied engineering, a domain where Microsoft has deep experience and resources. The pace is accelerating, and the implications are enormous. While quantum computing has many potential applications, the first real-world impact is expected in chemistry. Classical computers struggle to simulate complex molecules and reactions, but quantum machines can model these interactions with stunning fidelity. That means faster drug discovery, breakthrough materials, and even better tools for understanding and combating climate change. Microsoft's Majorana 1 chip isn't just another step in the quantum race, it's a pivot point. A moment when the impossible starts to look inevitable. A knot tied in the fabric of quantum reality that might just hold the future together.